Recurrence relations. A recurrence relation is what we call a rule that creates a sequence. It needs a starting value and also it needs a rule. Now every time we apply the rule, it makes a number in the sequence. This is called an iteration. We like to use the least amount of words as possible, so we end up using symbols. We often use V, but it could be any capital letter. So the starting point can be V0 or it could be T0 or whatever the capital letter we use in our description. The number in the sequence after n iterations, so after we have done this sequence an n number of times, is Vn. So V5, for example, even though that is the 6th number in the sequence, that is after 5 iterations, so after I've done this sequence 5 more times. The next number in the sequence is found by, and that is symbolized by this here, Vn plus 1. We use this all the time for any description about saying what the next number in the sequence is. It's not literally plus 1. Example 8b.1. Determine the first 5 terms of the sequence generated by the recurrence relation. So we have m0 is equal to 8, and then Vn plus, and that should actually say m n plus 1 because we're using a m in this rather than v. So m0 is equal to 8, mn plus 1 is equal to 0.25 multiplied by mn, take away 8. So what does this mean in reality, that 0.25 mn? It means for each term, I'm going to times it by 0.25 and then I'm going to take away 8. So let's go and have a look at this in practice. So m0 is equal to 8, and then m1 is going to be 0.25 times by 8, and then we're going to subtract 8. So 0.25 is the same as saying a quarter of, and a quarter of 8 is equal to 2. Take away 8, and that's going to be negative 6. So that's the second term in the sequence. M2, 0.25 times by negative 6, take away 8. That's going to be equal to negative 9.5. We can then list those values accordingly as 8, negative 6, negative 9.5, negative 10.38, and negative 10.59. Example 8b.2. This is coming from the Northern Hemisphere timetable VCAA exam. The first 5 terms of a sequence are 2, 6, 22, 86, and 342. The recurrence relation that generates this sequence could be one of the following. Now this is interesting because I think you'll find that if we look at the gaps in between them, so that's an increase in 4, we'll notice that the next one is more than an increase in 4. It's actually going to be an increase, well, 6 plus 4 gets me 10 plus another 12, so that's an increase in 16. And then 22 into 86, oh, I might grab my calculator for this one if you don't mind. Let's get this 86 take away 22. That's an increase in 42. And then 342 take away 86 is equal to an increase in 256. So it's not going to be just a simple ordinary plus a number, take away a number. We're going to be doing some multiplying at some point, it looks like. So the way that I would do this is I would start by eliminating all the options that it couldn't possibly be. So option A says that the initial number is P02, and where every number is found by just adding 4. Nope, certainly not that one. We can cross that one out. Okay, P0, so B is Pn plus 1. It's 2 times the sequence, or the term, sorry, 2 times the term plus 2. So, if we've got 2, 2 times 2 is 4, plus 2 gets me 6. Well, that's handy. Let's see if it works again. 2 times 6 is 12, plus 2 is 14. Well, it's not going to be B either. C. Is the sequence found by just multiplying each term by 3? 2 times 3 is 6, tick. 6 times 3, though, is 18. I was about to say 24. No, that's 8 times 3. 6 times 3 is 18. So, no, it's not going to be C either. So, D is suggesting 4 times the term, take away 2. All right, maybe. Well, let's go and see. So, I'm going to do 4 times each term and then take away 2. So, starting with the first term, which is 2. 4 times 2, take away 2 is 6. So that works so far. 6 times 4, take away 2 is 22. Well, that seems to work. 22 times 4, take away 2. That gets me 86. 86 times 4, take away 2, gets me 342. It is definitely, in that case, D. You'll notice there I went to the effort of checking every single term. That is very useful to be able to do, just in case there's often like one little trap. It will seem like you're picking the right one for the first 2 or 3 terms, and then suddenly the last one is different. Always check all the terms that you've been given. Example 8b.3. How many terms of the sequence formed from the recurrence relation below are negative? So this could be a very long and tedious process, but thankfully the CAS calculator comes up with the goods for us to be able to identify this. So it starts at negative 30, and then we're halving it and plussing 8. So right, you could do this by hand, but honestly, it's much better to use the CAS. So here is the CAS, the main menu. If we actually scroll to a side that we don't tend to scroll to, which is the second window, you'll see a button that says Sequence. So click on the big old sequence, and this is what comes up. So the first thing we need to do is to enter the formula, or the recurrence relation, which says 0.5 mn plus 8. So 0.5, we don't need to worry about m's, just use the calculator default, which is A. We're going to plus 8. And what we're going to do is we'll put a starting value of negative 30. Now you'll see a little X and Y here button here. I'm going to press that. Just make that start with 0. And then let's say we'll move to 100 values. And then we've got this table here. And then we can see in that list there, only 2 answers come up as negative. So we can say that the answer to this is that there are only 2.